10.4, use inscribed angles. The inscribed angle is an angle whose vertex is on the circle. So it looks something like this. Okay. Intercepted arc is the arc that inscribed angle runs into here, intercepts. So this would be the intercepted arc. An inscribed polygon is a polygon whose vertex, and I guess that would be vertices, since it's plural, lies on the circle. The shape inside of a circle. A circumscribed circle is a circle that is inside of a shape like that. Okay? So inscribe, the shape is inside. Circumcise, the circle is inside. Okay, theorem 10.7. Measure of an inscribed angle. The angle inscribed is half of the arc. So, measure of AB. So if this is maybe close to 180 degrees, then this would be 90. Okay, so let's look at an example. Find the indicated measure in circle P, the measure of angle S. Here is our angle S. What is its intercepted arc? It's 60, and so the angle's half that, so the angle is 30. Now we want the measure of Q to S. Q to S is a minor arc. What is its angle measure? It's 37. So now we need 2 times 37, and that's 74. Now, because major arc RSQ, RQS is a semicircle, then R to Q equals 180 minus 74, and that is 106. So let's look at that again. RQ to S is a semicircle. Then just R to Q would be 180 minus this. Okay? Okay, example 2. These are common problems. I'll describe them as the hourglass shape. So on the hourglass, if you'll notice that this angle F intersects the arc HJ, but if you keep noticing, G intercepts the same arc, HJ. So what does that mean? That means that angle F and angle G are the same. They're both 39 degrees. And then this arc would be twice 39, and that is 78. Okay? And so HGJ would be 39 also. So these are congruent. Okay, so theorem 10.8 tells the same thing. If two inscribed angles of a circle intersect the same arc, then the angles are the same. So ADB equals ACB. ACB. Okay. Example 3, name two pairs of congruent angles. We won't actually write this, but P is congruent to Q, and then S is congruent to R. Notice that P and S don't have to be the same measure. They just have to be, S and R have to be congruent, but not all four have to be the same. Go ahead and do the checkpoint at the bottom and start the video again when you're done. Okay, theorem 10.9. If a right triangle is inscribed, remember inscribed means that the shape was inside the circle, then the hypotenuse is the diameter of the circle. You might want to try this. There's no way to draw a right triangle unless it goes through the middle of the circle. Conversely, if one side of an inscribed triangle is a diameter, then the triangle's right, and the angle opposite the diameter is a right angle. So example 4. A security camera rotates 90 degrees and needs to be able to view the width of a wall. The camera is placed in a spot where the only thing viewed when rotating is the wall. You want to change the camera's position. Where else can it be placed so the wall is viewed in the same way? Well, from theorem 10.9, you know that a right triangle is inscribed inside the circle. Then the hypotenuse of the triangle is a diameter of the circle. So draw the circle that has the width of the wall as a diameter. The wall fits perfectly with the camera's 90-degree rotation from any point on the semicircle in front of the wall. Theorem 10.10. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Now notice that this is different than a parallelogram. We're not saying that this is a parallelogram, because in a parallelogram, remember, the adjacent angles are supplementary. But if we just have a quadrilateral in here, then opposite angles are supplementary. All right. Example 5. Find the value of each variable. So this is a quadrilateral inscribed in a circle. So opposite angles will be supplementary. That means they have to add up to 180. So P and Y, if P is 100, then Y is 80 degrees. And Q and S, they have to add to 180. So 180 minus 88 is 92 degrees. Okay, now let's do the same thing for circle B. And let's talk about this. Okay. At first glance, it looks like we can't do anything with circle B. We don't have any numbers. All we have is letters. But we know that J and L. So we know that together J and L equal 180. So 8x plus 4x equals 180. 12x equals 180. What's 180 divided by 12? 15. So x equals 15. Now, again, if we wanted to get the, say if I ask you what angle J equaled, remember to go back and substitute 15 into angle J's equation. Okay? All right, let's do K and M. Again, together they equal 180. So 3y plus 3y equals 180. 6y equals 180. So y is 30 degrees. All right, go ahead and try the 2 checkpoints, and I will see you next video.